Okay, yeah, so this is definitely like a challenging problem. So in this question, we're told that when we have a positive integer n, and if we feed it into this machine, then the output number is calculated by uh, the following rule, which is like they were nice and they gave us the nice visual here. If n is even, then you're just gonna divide by 2. So that's pretty simple. If n is odd, then you're gonna triple n and add 1. So they give us an example. They're nice enough to give us an example. If n equals 7, then the machine will output 3 times 7 plus 1, which gives 22 because 7 is odd. And then they give us a further explanation on like what would happen if we continued to like insert the output. So 7 goes to 22, 22 goes to 11, 11 goes to 34, and so on. We're told when the same 6-step process is applied to a different starting value of n, that final output is 1. And we want to know what is the sum of all such integers n. So yeah, this is definitely like a really like interesting problem. Because like this is kind of hard to like understand like how do we like start approaching this problem. So like one intuitive way when you just first look at this problem, like you might maybe the most common way of thinking about it is, oh, okay, so if I start off with a number n, then I can do casework if n is even and if n is odd. So if n is even, then I know the second number must be n over 2. And then you can keep doing casework like that if n over 2 is even or if n over 2 is odd. But the reason this will be like a not very good strategy is because like you're gonna have like a lot of like cases. Like it's just gonna be too much to check. Like you're basically given no information about the beginning. Like you're just told an integer n is going to be put into the machine and stuff is going to happen. But like you don't really know anything about the number n, so it's kind of hard to work with. On the other hand, if you start at the end, we know that the final output must be 1. So that's a common problem-solving strategy. You always usually want to like start with the information that you know and work your way that way. So we know the final output must be 1, so it might be a good idea to start from the back and work towards the front. So we know that n has to output some number, and that number has to output another number. That number has to output another number. That number has to output another number. That has to output another number. And finally, that last number outputs a 1. So what we can do is we can work backwards. So notice that like if the last number is a 1, so let me just write it here. N goes to n over 2 if n is even. And it goes to 3n plus 1 if n is odd. So basically, we can take a look at what can the second to last number be. If we have like second to last number and it outputs a 1, what can the second to last number be? It turns out like the only possible number that can go here has to be a 2. Like there's no other way. Like clearly 2 works, right? Because 2 is even, so 2 divided by 2 yields 1. So that makes sense. And it turns out like it's not hard to show if you test out other numbers. Like you can test out 1, 3, 4, 5, 6. Clearly none of them are going to generate 1. So it turns out like 2 is like the only possible second to last number that can like occur. So that means 2 must go there. Now let's take a look at this like third to last number, this one highlighted, circled in blue. If we know that this blue number, if we put it into the machine and it outputs 2, then what can that blue number be? Okay, well, let's say we called it x, for example, right? If x is even, then clearly x can equal 4, right? If x is 4, then you can just immediately divide by 2 and you get 2. Now, if x is odd, then you would do 3 times x plus 1. And if you set that equal to 2, you get x is 1/3. But like that clearly makes no sense because x has to be an integer. So that tells us that x equals 4 is the only possibility for this number in the blue circle here. So we can replace this with a 4. And this is pretty cool because we already know no matter what the sequence is going to be, the last 3 numbers are always going to be 4, 2, 1. And now let's take a look at this like this circle here, this like red one, this red circle, what can this number be? This one is slightly more challenging because it turns out this red circle can have two possibilities. It can be a 1 or it can be an 8. The reason it can be a 1 is because it's like pretty easy to verify. If you just do 3 times 1 plus 1, that gives 4, which works. On the other hand, 8 is even, so 8 divided by 2 is also 4. So that tells us 8 and 1 are both like possible candidates for like what goes in that circle there. So now we kind of have to do some more casework, right? So the first case is if like this number, let's say this number is 1, right? That's our first case. Now, if that number is a 1, we can use like a similar logic that like these two numbers have to be 2 and 4. Like with the same logic we did here, we can deduce that that these two numbers must be 4 and 2, 2 and 4. So then n in this case, it's pretty easy to determine that n can either be 1 or 8, like a similar reason here. Like it kind of repeats sort of. So we already found two possible values of n. N can be equal to 1 or n can be equal to 8. But clearly, like that's not all. We still have to consider when this thing in the red circle here is equal to 8. So let's consider that case then. If this number here is equal to 8. Now, if that number is equal to 8, then what can this number be? Let's call this number x. If x is even, right, then we have to have x over 2 has to give us 8. So that tells us x can be 16. Now, if x is odd, then we need 3x plus 1, because now we have to use this formula. 3x plus 1 has to generate 8. But then if we solve, we get x is 7 over 3, which is not an integer. So that yields no possible solutions, which tells us that x equals 16 is the only possible thing that can go in this black circle right there. So there's no other choice. So 16 has to go here. And now we're almost done. Let's take a look at what number can go in this like green circle here. It turns out it's not hard. We can repeat the process again. The number in this green circle can either be 5 or 32. Because if we take 5, we can triple 5 and add 1 from here, and we would get 16. 3 times 5 plus 1 is 16. Or we can take this 32 and use this thing here, n divided by 2. 32 divided by 2 is also 16, which also works. So 5 and 32 are both possible candidates for this green circle here. So now we have like just like two last cases to check if this green circle is 5 or if this green circle is 32. So let's first take a look at what if this green circle is 5? Then what can n be? Well, it turns out the only possible value of n is 10. 10 divided by 2 clearly works. That gives 5. You can't have 3 times n plus 1 be 5, because then n would be 4/3, which again is not an integer. So we can disregard that. So we can conclude that n equals 10 is also a solution to this question. And the final case that we have to consider is when this green circle is 32. When it's a 32 there, then it's not hard to see that this value of n here can be 64, right? Clearly 64 works, because if you just do 64 divided by 2, you immediately get 32. But if you try to, again, if you try to do 3n plus 1 equals 32, then you get n is 31 over 3, which is not an integer, which means that 64 is the only possibility in that case. So n can also equal 64. So those are the only 4 possibilities, since we kind of worked backwards and checked all of the possibilities there. So now the question just wants us to find what is the sum of all integers n. So to do that, we would just add them 1 plus 8 plus 10 plus 64. And that would give us 83. And that would give us choice E, which is the correct answer.